All right, today we're talking about solving compound inequalities. So, a compound inequality, the short explanation of that is two inequalities that we're combining. So, we can combine those inequalities using either the word and, which means we're talking about where they overlap, or using the word or, which means we're talking about connecting them together. So, let's take a quick. So, this one says a compound inequality that is an inequality formed by two inequalities using either the word and or the word or. So now I'm going to show you what that means. So when it says and, that means we're talking about where these two things would overlap. So this first one, I'm sorry that it's a little bit fuzzy, but it's going between -6 and it's a closed dot, so we want the or equal to, and all the way up to 3. And this is an open dot, so I don't want the or equal to. But really what's happening here is we're combining x is greater than or equal to -6 and x is less than 3. So you can write it either way. This is the way that you'll probably see problems start out the most, but you could write it this way too. Both are totally acceptable. So when you would graph this, x is greater than or equal to -6 would be all the way this way. X is less than 3 would be all the way this way. So we're just talking about this green section where they overlap now. That's what it means when we say and. We're talking about the overlapping. So where they overlap. Okay, so if I was going to write one for this one, I have, looks like 5, -5, and there's no line underneath since it's an open dot, and we're going all the way up to 4. This one looks like we're doing -4, and then you would have the or equal to up to 5, and it would also have the or equal to. And then example D here, we're going from -3 up to 6. So this is how we write compound inequalities for and. So they either, if they're written like this all in one, then we know automatically that they're and, or they have to physically use the word and. So for or, they can only be written out like this with the word or in the middle. There's not two ways to write them. And or means that we are joining the two pieces. So this one is written as x is less than or equal to 5, because we're going to the left, or x is greater than 3. So we're just excluding this piece in the middle. Okay, so it's going two different ways, but in or, that's what happens. All right. So if I was going to write this one, I have x is less than -5, or x is greater than or equal to 4. C, we have x is less than or equal to -4, or x is greater than or equal to 5. And then example D here, we have x is less than -3, or x is greater than 6. Right? So there is no fancy way to write ors. They all have to be written this way. All right, so now let's take a look at some examples. So this is an and, just FYI. If it's written all in one like this, it has to be an and. So that's just a side note. But when we are solving these, we have to do whatever we are going to do to one side, we have to do to all three sections now. So I'm trying to isolate C here. So that means that I'm going to do my two-step. But when I add 6, I'm adding 6 to all three sections. So this will be 28. And over here we'll have 44. Then I would normally divide by 4, so I'm going to do that. I'm going to do it to all three sections. So our final answer here is 7 is less than C is less than or equal to 11. So that means C is any number or decimal that is between 7 and 11. All right, here we have an OR. So you'll solve these separately, kind of like how we do absolute value when there's 2, you'll just solve them separately. So here I'm going to add 2 to both sides. So y is less than or equal to -6. And then here I'm going to subtract 3 from both sides. So y is greater than 6. So we can plug in anything for y that is smaller than -6 or greater than 6, but that range in the middle between -6 and 6 are not solutions. All right, we're going to do a couple more. Here we have another OR, so we'll just solve them separately, kind of like how we do absolute values. So I'm going to subtract 5 from both sides. And divide by 2 on both sides. Then here I'm going to add 1 to both sides. And divide by 3 on both sides. So this says that we can have anything smaller than -8 and anything bigger than -2, but that range in between -2 and -8 are not solutions. What's in the middle of them? All right, this one written all in one is an AND problem. And it creates 3 sections for us. So the first thing I'm going to do is subtract 1 from all 3 pieces. So -4 is less than -2x is less than or equal to 8. And then we're going to divide everything by -2, which means we're going to have to flip our signs since we're dividing by negative. So we'll have 2 is greater than x is greater than or equal to -4. So we're saying that range in between -4 and 2 are our solutions for this problem. All right, so that's it for your notes for today. You do have a practice on big ideas.